Okay, we are on 4.1.3. This is the notes. This is the second page that you may not have in your packet, so either print it out or use another sheet of paper. Okay, so we're exploring more about the slope ratio and its connection to something we call tangent. Right. So right now it says start with a triangle slope of 45 degrees. What would happen to the triangle if the slope angle increases to 55 degrees? Which will be longer, the delta x or delta y, the rise or the run, right? So right now let's make a prediction and see which one do you think. If you were to make your 45-degree angle, which originally is right here, 45-degree angle, right? And you're now going to increase it to 55 degrees. So as I'm drawing this, probably you can see what's going to happen. As I'm drawing this, notice how my x went in, but then the y went up. So our rise increased, our run decreased. So I would say delta x, delta y longer, delta x shorter. Right? Again, you might want to draw this picture for yourself so you get an idea of how this looks. So it says, use the decimal tool to create a triangle with slope angle measuring 55 degrees. Use a resulting slope ratio to solve for the x in the triangle at the right. So I have the decimal tool lined up for you. So give me a second here. So this is the decimal tool that this book has provided for you. You start out with a 45-degree angle here. With a 45-degree angle, you can see the slope is 1 over 1. The rise over run is 1 over 1, 1 over 1, 1 over 1. Okay. Now visualize what will happen to triangle if the slope angle increases to 55 degrees. Which will be longer, delta x or delta y? Explain your reasoning. That's what we just did in the first part, right? Now I'm going to drag the green point to increase the angle. So notice how when I move this green point, my angle got bigger, right? So now it's at 51 degrees. We want 55 degrees. Okay, I went too far. 55 degrees. All right, so 55 degrees. Let's see, this is perfect. So 55 degrees. Okay, so use the result slope ratio to solve for the x. So delta y is 9.3. What is delta x here? Delta x looks like 1, 2, 3, 4, 5, 6, 6 point something, 6.5, a little bit more than 6.5. Okay, so, all right, well, we have an idea. So delta y is about 9.3. Delta x is about 6 point, I want to say 6.6, a little bit more than that, maybe 6.7. If we're a little bit off, it's really not a big deal. Okay, so it says use a grid to approximate answer. Right, so my delta x, so my rise over run would be 9.3 over, let me check again, that definitely is 6.7. Okay, so 9.3 over 6.7, that's my rise over run. Okay, let's go back to our document. Okay, so on my document, I wrote down my slope ratio of 9.3 to 6.7. And now we're going to use that same slope ratio because remember, the ratio remains the same. So now my triangle is a little bit different. The triangle in front of me now has an 8 over something. So that ratio has to be same as 9.3 over 6.7, which means then you go ahead and say, all right, equal this triangle here of the rise over run. Okay, now this is algebra. We can cross multiply. I don't think I can do a little multiplication shortcut here. So I'm going to cross multiply and say 9.3 times x is equal to 8 times 6.7. All right, so 9.3x equals, and I'm going to grab my calculator because no, I do not expect you to do this by hand. So 8 times 6.7, that gives me 53.6. And now I divide by 9.3 on both sides. I get my x is about 5.76. All right, so now that's how I use the slope ratio to help me solve for this angle, right? This missing side here, okay? All right, so we're going to use the slope ratio to help us find the missing side in a triangle. Remember, if the angle with the angle given, you now use the slope ratio to figure out what the rise over run is, and you set up a proportion to the problem. So let's take a look. Part A here, the first problem here says I have a slope angle of 70 degrees, and the problem is I have x and I have 10. Okay, so first thing you want to do is go over to the right, your chart here. The chart says 70 degrees has a slope ratio of 13.737 over 5. All right, so that's my slope ratio. So I write 13.737 over 5. Quickly check. Yes. Okay. Now that's equal to, okay, what's in my problem here? My problem has a rise over run of x over 10. Okay, now I can go ahead and solve for the x. So I can use my multiplication trick in this case, because I can see, 5 times 2 is 10. So times 2 up here. So 13.737 times 2. It gives me x is 27.47. Right? Just round to 2 decimal places. That's plenty. That's good enough. All right. Okay. Now, part B is backwards. I don't know the angle, but I have the rise over run. So let's take a look. In my problem, I have my rise is 50, run is 6. Okay, can I reduce this? Sure. Let's reduce the fraction and see if that'll get us closer. If I reduce by 2, I get 25 over 3. 25 over 3 is about 8.33. So let's see if that will help me. All right, so let's go ahead and look at my ratios here. I need a 25 over 3 or a 8.33. Ooh, I have it right here. That is the ratio, right? So that's the ratio. Moving over to the other side, my angle is 83 degrees. So here I can say my angle, this is called theta. Theta, it's simply an O with a bar in the middle. So theta, you go O with a bar. Theta is 83 degrees. All right. So just a quick note, why is it called theta? In math, the variables represent a number for us, but when we use different variables, it tells us a little bit more information. For example, if you were solving for x comma y, we know we're solving for a point. If we're solving for a theta, we know it's solving for an angle. When we use Greek letters, it's typically an angle. What are some other examples? If we use n, we know we're dealing with something in a sequence or a series. Or I, again, you'll see a lot of this later. I is imaginary, so it's part of the complex numbers. So variables tell us different things. It gives us a little bit more information than just, it represents a number. Okay. All right, next one, we're solving for an angle again. So we have this angle here that we don't know, but I know the slope ratio is 10 over 1, rise over run. So 10 over 1. I can't even reduce that, so that's already reduced. Let's take a look. I think you already saw it. You spotted it underneath. 10 over 1, that's an angle of 84 degrees. And that's it. That's all you need to do. Theta is 84 degrees. Right. So this slope chart is very, very helpful for us. It's going to help us figure out all the different problems in here. Okay, now I have an angle this time. I have an angle of 8 degrees. Okay, so that means I need to go up here in my slope chart. 8 degrees has the ratio, I'm going to pick the smallest ratio here, 26 over 185. So I have 26 over 185. Okay, equals, what's in my problem here? My rise is 20, my run is x. Okay, now I can't use a multiplication problem here because 20 doesn't really go into 26 very nicely. So I'm just going to cross multiply like I usually do. So 26x equals 20 times 185. 26x equals, let's see, what is 185? 185 times 20, that gives me 3,700. So if I divide by 26 on both sides, I get about 142.31. So x is about 142.31. So again, remember the proportions will always be the same. Okay. All right. Next one, we're going backwards again. We're looking at the angle that gives us this ratio, right? So I have this rise over run. I have 0 over 14. 0 over anything is 0. If I have 0 for my ratio, I have 0 degrees, right? 0 is 0 degrees. So this one has no triangle at all. So here, this one has theta equals 0 degrees, which means no triangle, right? Because if 0 degrees, it's flat. There's nothing there, so no triangle here. Right, it does say if you cannot find the x value, so we need to talk about that. Okay, next one, I have 89 degrees. Ooh, 89 degrees. So I'm gonna look over here. 89 degrees has this really awesome ratio. Oh my goodness, 5,729 over 100. 5,729 over 100. All right, that is some big fractions there. All right, so equal to rise over run, x over 2. Okay, well, I could do a multiplication here, or actually a division here, right? 100 divided by 50 gives me 2. So if I divide top by 50, 5,729 divided by 50, it gives me x is actually equal to 114.58. All right, beautiful. Okay, so now next one, part G here, says 90 degrees. So I know 90 degrees. Now what is the ratio if I have x over 6? Now, be careful. Notice my chart stops at 89. So what about 90 degrees, Miss Chu? Well, is this triangle even possible? You have 90 degrees here, and this is also 90 degrees. So you already have two 90 degrees, which makes 180. Is this triangle possible at all? No. So no triangle, right? Because you have two 90-degree angles. Okay, so that's it. Your homework tonight will be asking you to use this chart a lot. So make sure you do try to use the chart and see how we use it in class in the homework. Okay, all right, that's it.